Okay, so this is spectrum number 1, and as always I'm going to start with the mass spectrum and the empirical formula. So I see that C2H5X, and then X is a halogen. So C2H5X, that means that the molecular formula is C2H5X or C4H10X2. Alright, and I look and I glance over here and I don't see what I would expect for bromine, which would be something like that, right? With a molecular ion peak as that. And chlorine would be a 1 to 3. So it's either fluorine or iodine, right? And the molecular mass of iodine, do you have your periodic table? The molecular mass of iodine is 127. So I immediately see, thanks, I should have had that ready. The molecular mass of iodine is 127, so thanks very much. So I see, look at that, 126.9, I can't even read that, but hopefully your eyes are better than mine. 127, and I see that that's 127. So I'm gonna assume it's iodine for now, and we'll see what that gives us, okay? C2, that's 2 times 12, plus 5 times 1, plus 127, gives us 24, plus 5, plus 127, gives us 29, plus 127, which is equal to 156. And boom, there's 156, okay? So this then is the molecular weight, and these are the notes I'm going to make on my exam. Molecular weight, therefore, molecular formula is C2H5I. Okay? Now I go to my second step, which is I start to make guesses. What could that be? C2H5I. And you know what? I pretty quickly realize that there's only one possibility for C2H5I. That's it. That's all it can be. There's no other way I can arrange those atoms. I'm confident that it is C2H5I because my mass spec has my molecular ion peak at 156. So before we go any further, let's predict what the IR is going to look like. The only IR peak that we're really sure is going to be on there is sp3H, right? That's the carbon-hydrogen bond for sp3s, which is about 3,000. And that's it, right? On our sheet we don't have anything else. So I look here, I see that there, and I'm going to write CSP3H. And here's my 1500 line, so I don't care about anything past that point, and that's all the only peak I have. So this is consistent with my C2H5I. Now the next thing I'm going to do is I'm going to go and make my predictions for NMR. And what I do for that, if this is my compound, then I say how many different kind of hydrogens do I have there? 1, 2, okay, and I'm write out my trusty table, type, number, n plus 1, and shift. Notice we have not looked at the NMR yet, so we're just doing this so that we can, when we look there, we find if it's consistent with our predictions. A has 3, there are 3 hydrogens that are A. They have 2 neighbors, which are B. Therefore, it's going to be a triplet, and its shift is going to be about 1. All right, actually, let's pull this list out. Thank you. Let's pull this list out here and see for our NMR values. CH3s at the end are about 0.85. Can you see that from where you are? Okay, 0.85. So I'm going to put 0.85. If it's not exactly 0.85, I'll be fine with that. And then we're going to look at a carbon which is next. This guy, right, is next to an iodine. So we're going to go, there's a carbon which is next to an iodine. That's 2.5 to 4. That's a pretty big range. 2.5 to 4, but I'm going to write that down on my sheet. And I see that there are 2 that are B. See, there's 2 hydrogens there. How many neighbors do they have? 3. Therefore, it's a quadruplet. All right, now let's go to the HNMR and see if that's consistent with that. Do I have a triplet around 1? There's my triplet, and it's pulled up from 1. It's not exactly at 1, okay? But it's close, and we see that iodine pulls things upfield a little bit, right? Normally sp3 hybridized carbons are going to be around 1, and so that gets pulled upfield a little bit. That doesn't bother us that that's upfield. Doesn't bother us at all. Oh, and by the way, it has the area under the curve is 3, which is what that is. Okay? Oh, I said triplet. Yeah, it's triplets because of that. Okay? Now look at, we're also looking for a quadruplet, which has an area under the curve of 2. And that's going to be further upfield. And that's exactly what we have. A quadruplet, which is 2. So that's going to be B. Okay? And so the structure is that. Boom. And that's 100% on that question. If that were the question you got in the exam, that's exactly the steps you would take.